All right, guys, today we're going to end up learning a bunch of new derivative rules, and we're not going to just have them come out of nowhere. We're going to come up with them ourselves using rules we already know. So as a warm-up, let's make sure we know a few things. Find dy dx if y equals sine of x. And hopefully we've all memorized it at this point and know that y prime or dy dx is equal to cosine of x. Similarly, the derivative of cosine of x, if we have y equals cosine of x, the derivative is negative sine of x. So these are the two basic trig derivatives we should know. This says find f prime of pi over 2. So what is the slope of f of x at pi over 2? So, here's cosine of x, and it wants us to find what is the actual slope when x is pi over 2. And so hopefully we're able to get that. And if we weren't, remember that when we're trying to find the slope at a specific point, we usually try to come up with the general formula first because it's easy. So the general formula for the slope at any point for cosine is negative sine of x. And now we want to do f prime of pi over 2. Notice I have put in pi over 2 instead of x because this is the slope at any x. This is the slope when x is pi over 2, and it will be negative sine of pi over 2. Now, you do need to know your trig values. The unit circle here is 0. Here it's 0 and 2 pi is all the way around the circle. That's the circumference of a circle. So halfway around the circle would be pi, and so pi over 2 is right here. And the sine value is how high it is. It's the unit circle, and so that is 1. So sine of pi over 2 is 1, and so we get negative 1. And that tells us that the slope, which corresponds to this point in the graph, the slope of cosine of x at x equals pi over 2 is negative 1. The slope is negative 1 there. Okay. So rewrite tangent of x using sine and cosine. And hopefully we're all able to do that. But if not, oh wait, there's no y equals. So tangent of x is sine of x over cosine of x. That's definitional. So this is tangent. I guess I should say tangent of x is equal to that. And so what is the derivative of tangent of x? Well, if y equals tangent of x, we don't have a rule for this yet, but we can find it by rewriting it. Notice I'm not putting y prime yet. We can rewrite it as sine of x over cosine of x, and now you can do the derivative. And go ahead and do that yourself. You should be able to do it using the quotient rule. But if not, the quotient rule, let's remember, is the derivative of the top. So the derivative of sine of x is cosine of x. So this is y prime. The derivative of the top times the bottom minus, we leave the top alone and multiply it times the derivative of the bottom. And the derivative of the bottom in this case is the derivative of cosine is negative sine of x over the bottom squared. So cosine squared of x is how we usually write that. Now there's some cool things we can do to simplify here. I'm going to rewrite it over here. Cosine of x times cosine of x is cosine squared of x. Here we have a negative times a negative, which is a positive. Sine of x times sine of x, we usually write as sine squared of x. And then the bottom was still cosine squared of x. And hopefully we remember from pre-calculus, what is sine squared of x plus cosine squared of x? That's my favorite trig identity. Well, sine squared of x plus cosine squared of x is 1. And I hope you guys know that comes from the Pythagorean theorem. It's just like the Pythagorean theorem on the unit circle, because the unit circle, so here's a squared plus b squared equals c squared, and because the unit circle is 1, so you've got sine squared plus cosine squared equals 1. Okay, one last thing. This is kind of okay, but there's a cool way to rewrite this, because 1 over cosine of x is equal to what trig function we should know? This is secant of x, and so 1 over cosine squared of x is secant squared of x. And this is usually how we write the derivative of tangent of x. And this is something we'll memorize. We'll talk about that later today. So if you have y equals tangent of x, the derivative is secant squared of x, and it comes from just the quotient rule and then using some trig identities. Okay, let's see where we're at. We should know 2 different ways to do this, to find f prime of x for this kind of function. Those 2 ways are the quotient rule, because it's dividing. So it's 2 things that we know how to do the derivative of dividing by each other. Or the easier way, when remember, you should be able to like avoid using the quotient rule whenever possible. And because there's just a monomial in the denominator where it's just one thing, we can just simplify first by dividing, then do derivative, then derive. Okay, so let's do the quotient rule first. So go ahead and do this using the quotient rule. So f prime of x is, it's the derivative of the top, which is, this is power rule, so multiply by the power, 6, and lower the power by 1. Plus, this is a sum and difference, so we can do each one of these separately. The derivative of x squared is we multiply by the power and lower the power by 1, which is just x. And the derivative of a constant is 0. So this is the derivative of the top times, and since I'm multiplying times a binomial, I need to put it in parentheses, times x squared, minus, we leave the top alone, and since we're going to be multiplying, I need to put it in parentheses, times the derivative of the bottom. So the derivative of x squared is 2x over the bottom squared, x squared squared. And remember that when you do a power to a power, we multiply those powers. So this can be simplified. The x squared can distribute, and we can get 6x to the 4th plus 2x cubed. This minus will end up distributing, but first I'm going to multiply by this out. So I'm actually going to go ahead and just distribute this minus. It's going to be minus this one, minus this one, minus this one. So minus 2x cubed times 2x is 4x to the 4th, minus 2x times x squared is 2x to the 3rd, minus 6x. Notice that that minus, of course, distributed to all of these also. And I could have done that in 2 separate steps. Divided by x to the 4th. And I want to combine any like terms. And so this is 2x to the 4th. 2x cubed minus 2x cubed is 0. So minus 6x over x to the 4th. And this is an okay way to leave it. I guess I could divide everything by x, or I could even separate it and go slightly differently. So let's see. Does simplifying and then dividing work out any better? Well, first, when we're simplifying, we should rewrite this as f of x equals, so we're going to divide each of these by x cubed. So 2x cubed divided by x squared is 2x. We subtract the exponents when we're dividing. X squared divided by x squared is 1. And 3 divided by x squared cannot be simplified, but I am going to go ahead and write it. I know it's a power rule. 3 over x squared is 3 times x to the negative 2. And so now I can take the derivative, and the derivative of 2x is 2. The derivative of this is a power rule. I need to multiply by the power, so minus 6, because negative 2 times 3 is negative 6, and lower the power by 1. And I'll rewrite this at the end, because I don't leave negative exponents. Negative exponents tell me to divide. So are these the same? And one skill we need is, because the AP exam is 50% multiple choice, sometimes you could do either one of these legitimately, but either one of these could actually be the answer on a multiple choice test. And so we need to see, is there a way to like make one of these into the other one? And I hope we see that here, this is still dividing by a monomial. And so this can be rewritten as 2x to the 4th divided by x to the 4th, which is 2. And minus 6x divided by x cubed, one of the x's will cancel out, and we'll get minus 6 over x cubed. And so these are, in fact, the same. We can just divide here. So these are 2 methods. I hope we agree that this one is way easier than all of this. One of them is much shorter. So remember that just because there's a quotient doesn't mean you shouldn't try to do other ways. Okay, let's look at 2 special examples that the AP exam loves to pull. Not necessarily like, well, they've done it like this before. Limit as h goes to 0 of x plus h to the 7th minus x to the 7th. Now, over h. Now, we could expand this, and we did talk about how to use Pascal's triangle, that thing that went like this, to figure out what the coefficients are. And we could do it. It would be okay. But this is not the way it's intended to be done. Instead, what the AP exam means for you to do here is to recognize that this is the limit definition of the derivative, the one where h is going to 0. This is the limit as h goes to 0 of f of x plus h minus f of x over h. Do you see the x plus h to the 7th and the x to the 7th? This is, so the question is, what is the f of x here? And here, f of x is x to the 7th. And so f of x plus h is x plus h to the 7th minus f of x over h. And so you're supposed to recognize that this is the limit definition of the derivative. And so this is equal to f prime of x. It's the definition of the derivative of this function. So if f of x is x to the 7th, this whole thing is just, you can use the power rule. It's 7x to the 6th. This is a power rule in disguise. You're supposed to recognize that this is the limit definition of the derivative and that you can do the power rule of it and get there. It's one of the 8 ways the AP exam tests that you actually know the limit definition of the derivative is by hiding things in the limit definition of the derivative that as soon as you see that it's like, oh, it's just asking for the derivative of x to the 7th, then it's super easy. The same thing is going on here. You could do this by doing long division. Long division is fine. But do you see how the denominator is going to 0? If the denominator is going to 0, then this is pretty much guaranteed to be the definition of the derivative. But this is the derivative at a point because x is going towards 2. This is f prime of 2 is equal to, remember, it's f of x minus f of 2 over x minus 2. And so when you see this x minus 2 like this is the limit definition of the derivative at a point. So the question is, what is the f of x? Well, f of x is just going to be this thing. And when we plug it in, you can see that f of 2, so f of x is going to be the part that doesn't have this. So f of x equals 3x to the 4th plus 2x. And f of 2, 2 to the 4th power is 16. 3 times 16 is 48. 2 times 2 is 4. And so f of 2 is 52, and you can see that it's f of x minus f of 2. And so this is the limit definition of the derivative of f of x at 2. So, well, how do we do f prime of 2? We don't have to do long division. We just need to recognize that this is f of x minus f of 2 over x minus 2, and so it'll be the derivative of this at 2. So f prime of x is equal to, we just do the power rule, we multiply 12x cubed plus 2. And so then f prime of 2 is, we just plug in 2 here, 2 to the 3rd power is 8. 8 times 12 is 96. 96 plus 2 is 98. So be on the lookout. When you see limits, we learned how to do derivatives using limits. But you can also use derivatives to do limits by recognizing that it might fit the limit definition of the derivative, and this will happen often. So yeah, practice this for just a second and we'll see how it goes for you. All right, moving back to our warm-up, I want you guys to try to do this on your own. If f of x equals tangent of x, determine f prime of x. What was the technique we used in our warm-up? Well, hopefully we remembered that we rewrote tangent of x as sine of x over cosine of x. And now we can use the quotient rule on it. So the derivative is equal to sine of x, the derivative of the top, times the bottom, minus, we leave the top alone, times the derivative of the bottom, negative sine of x, sorry, the derivative of cosine is negative sine of x, over the bottom squared. So there's the quotient rule. And hopefully you can simplify this on your own from earlier, but if not, let's try it. Cosine is cosine squared of x. Negative sine times negative sine is positive sine squared of x, divided by cosine squared. And there is one trig identity we're supposed to know here, which is cosine squared plus sine squared equals 1. So 1 over cosine squared, and 1 over cosine you're supposed to know is secant. So this is secant squared of x. And this does need to be memorized. So f prime equals secant squared of x. We'll be talking about at the end of class today how you should make some flashcards to make sure you've memorized everything. And so secant squared of x is the derivative of tangent of x. You just want to be able to see that. Here's a new one. Now, to be able to do this one, you do need to know from pre-calculus what is cotangent of x equal to. So cotangent of x is equal to cosine over sine. And now you can use the quotient rule to find the derivative yourself. So the derivative is equal to the derivative of the top. The derivative of cosine is negative sine of x times the bottom, left alone, minus, we leave the top alone, times the derivative of the bottom over the bottom squared. Here we have sine of x times sine of x, which is negative sine squared of x. Here we have a negative times a negative, a negative times a positive, which is a negative cosine squared of x over sine squared of x. And whenever you see a sine squared or a cosine squared plus or minus something, you should really be thinking, is there a way to use that Pythagorean identity? And this one's a little trickier. Remember the main Pythagorean identity you're supposed to know is sine squared plus cosine squared equals 1. Well, is that what this is? No, but we can get there. There are two ways to do it. Moving the sine and the cosine over to the other side would make them both negative. Then you could just move the 1 over to this side. Or, because they're both negative, you can just multiply everything by negative 1, which is what I'm going to do. And we'll get negative sine squared of x minus cosine squared of x equals negative 1. We multiplied both sides of the equation by negative 1. And so this whole thing becomes negative 1 over sine squared of x. And this is another trig identity we're supposed to know. What is 1 over sine of x? Well, 1 over sine of x is equal to cosecant of x. So this is negative cosecant squared of x. And so this is another one we're supposed to memorize. If f of x equals cotangent of x, then f prime of x equals negative cosecant squared of x. Okay, this next one, we're going to find the derivative of secant of x. So f of x equals secant of x. So same thing. How can we rewrite? We don't have a rule for secant of x yet, and so we're going to rewrite it as a quotient. What is secant of x equal to? Well, this is 1 over cosine of x, and this is a quotient, so you can do the quotient rule on it. Go ahead and do that. So the derivative is the derivative of a quotient is the derivative of the top times the bottom left alone, minus, we leave the top alone, times the derivative of the bottom, which is negative sine of x. The derivative of cosine is negative sine, over the bottom squared. 0 times anything is 0. Negative 1 times negative sine of x is positive sine of x. And we can simplify this by recognizing that there is a trig thing we should see. Sine of x over cosine of x is tangent of x. But there's this cosine squared, and so we're going to rewrite the bottom as cosine of x times cosine of x, because that way we get the sine of x over cosine of x. So sine of x over cosine of x is tangent of x times, to actually make this work out, so we need sine of x over cosine of x, that's tangent of x, times 1 over cosine of x. That way when we multiply across, we'll get cosine squared. And so 1 over cosine of x, this is like a 1 here, 1 over cosine of x is secant of x. And so the derivative is, we usually write, the derivative of secant of x is secant of x times tangent of x. So this is another one we're going to memorize. The derivative of secant, and you can do it without memorizing it, but guys, this comes up like as part of a problem. You don't want to have to do all this every time. These come up so often that you just memorize that the derivative of secant of x is secant tangent of x. The derivative of tangent of x is secant squared. And I'll show you a trick on how to memorize this later. Okay, f of x equals cosecant of x. Go ahead and try this one on your own. How do you rewrite it? How do you go from the beginning to the end? And hopefully we recognize that we can rewrite it. Notice that I'm not putting f prime of x yet. This is just the same thing, just rewritten. Cosecant is 1 over sine of x. And so the derivative, I need to use the quotient rule. It's the derivative of the top. Derivative of 1 is 0. Constants are always have a derivative of 0 times the bottom left alone. Minus, we leave the top alone, times the derivative of the bottom divided by the bottom squared. And this goes away. We get negative cosine of x over sine squared of x. And hopefully, just like before, we can recognize that we have cosine over sine. But I'm going to write this as cosine of x over sine of x There's another sine of x here because it's sine squared. So this is 1 over sine of x. And so this is negative cosine over sine is cotangent of x. 1 over sine is cosecant of x. So we usually write it in the other order, though. We usually say this is equal to, the derivative of cosecant is negative cosecant cotangent. That's the last one of the ones we're going to memorize from today. So that's the last of, oh man, I hope this wasn't off the screen the whole time. My goodness. We did the quotient rule. Okay. We split it apart and did it. Man, we'll take a look at this, make sure it makes sense. I'm sorry if that was off the screen. This is the last one we're going to memorize. Let's try to put our two skills together here. The limit as h goes to 0 of tangent of x plus h minus tangent of x over h. And let me just tell you, I could do this by using the sum and difference formula for tangent of x, but I think it would take me about 5 to 10 minutes to do this problem. I've done it before even, but like years ago, and I think it would still take me a while to do it. But that's not the way you're meant to do it here. Instead, what are you supposed to recognize this as? This is the limit definition of the derivative. This is, you've got limit as h goes to 0 of f of x plus h minus f of x over h. And what is the f of x here? Well, it's tangent. So this is tangent of x plus h minus tangent of x. And so the derivative, it's just asking you for what is the derivative. It's just asking you for what is the derivative of tangent of x. And that's one we want to have memorized. The derivative of tangent of x is secant squared of x. That's what this limit is equal to. Similarly here, try this one on your own. I hope we recognize that this is f of x plus h. So this is limit as h goes to 0 of f of x plus h minus f of x over h. And so what is the f of x here? Well, it's secant of x. And we just memorized what is the derivative of secant of x. The derivative of secant of x is secant of x tangent of x. And so that's what this limit comes out to be, because it is the derivative of that function. Okay, guys, hopefully we're feeling okay with this. We're going to spend a little time, this is kind of a hodgepodge today. We're going to spend a little time doing the second derivative, talking about what it means a little bit. We'll get much more into depth on the second derivative and what it tells us later. But let's remember that the second derivative is the derivative of the derivative. We write it as a few ways. We can write y prime prime, that means do the derivative twice. And you could write like y prime 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 for the third derivative, but we won't do the third derivative a lot. F prime prime means do the second derivative, and this would be like the third deriv, which is not super important. There are like a few, like the second derivative has a ton of actual real world applications, and the third derivative has way fewer. There are some, but it's way less important than the second derivative, so the AP exam doesn't focus on it as much. You will have to find the second derivative many times on the AP exam, and you may or may not have to find the third derivative at all. So you can write it as y prime prime. Similarly, the third derivative would be f prime prime of x, or d squared y dx squared, and the third derivative would be d cubed y dx cubed. So this is the third derivative. Sometimes when it gets to higher things above the derivative, they'll put like they'll put like f3 of x, not meaning x. They'll usually tell you like, hey, this isn't f cubed, it'll be the third derivative. Do the derivative 3 times. Sometimes they'll write it like this because it gets too annoying to write a bunch of primes. Okay, so find the second derivative of x, of f of x. And, you know, we just talked about that the second derivative means the derivative of the derivative. So what you're always going to do is first find f prime of x and then do the derivative of that. So go ahead and do that. What is the second derivative here? Well, we find the derivative of 2 sine of x. This is a constant multiplier, so we'll leave it alone. And the derivative of sine of x is cosine of x. That's the first derivative, but we wanted to find the second derivative. So we need the derivative of the derivative. This is a constant multiplier times the derivative of cosine of x is negative sine of x. And we can simplify this. A positive times a negative is negative 2 sine of x. Okay, why don't you guys try this one on your own? If f of x equals x to the 4th, what is f prime of x? F prime prime of x, sorry. F prime of x, so we are always find the first derivative first. This is power rule. 4x cubed we multiply by the power and lower the power by 1. And we're going to do the derivative of that as well. This is a constant multiple times a power rule. So we're going to leave the constant multiple alone and multiply by the power. So 3 times 4 is 12, and we lower the power by 1, and there we go, 12x squared. This one is a little harder. In fact, I'm not sure I have enough room here. I hope I gave myself enough room. F of x equals x sine of x. So what is the second derivative? Well, we find the first derivative first. This one is product rule. X is multiplying times sine of x. So we need to do the derivative of the first one times the second left alone, plus we leave the first one alone times the derivative of the second. And we don't need this one here, of course. 1 times sine of x is just sine of x. So that's the first derivative, but now we need the second derivative. So this is a sum or difference now, so we can do them separately. The derivative of sine of x is just cosine of x. The derivative of x cosine of x, well, this is a product. X is multiplying times cosine of x, so we need the product rule. So we're going to do the derivative of the first one, which is 1, times the second one left alone, plus we leave the first one alone times the derivative of the second one, and the derivative of cosine is negative sine of x. And this can be simplified because cosine of x plus cosine of x is 2 cosine of x, and x times negative sine of x, we always write the negative in front. A positive times a negative is a negative, so minus x sine of x. Okay. 4, the second derivative of 5e to the x. Well, the first derivative, it's a constant multiplier, so that's going to stay, times the derivative of e to the x. That's one we should know. The derivative of e to the x is just e to the x. The second derivative is the derivative of that. We have a constant multiplier, so it will stay, times the derivative of e to the x, which is just e to the x. And so the second derivative is e to the x, and in fact, like the fifth derivative would still be 5e to the x. Every time you take the derivative of e to the x, it just stays e to the x. It's one of the really nice things about this function. Okay. How about this last one? What is the second derivative here? Well, we want to rewrite this. We could do it using quotient rule, guys. I sure hope you didn't do this during doing quotient rule. It's so much easier if you just rewrite it as a power. Okay, so then I guess I should have called this f of x equals. I'll change that. So, or y equals at the very least. I'll put y equals. Okay, so y prime then equals, we multiply by the power and lower the power by 1. So negative 2 minus 1 is negative 3. And we are not going to rewrite it because we want it as a power rule because we're going to do another derivative real quick. So the derivative, again, we're going to multiply by the power. So negative 3 times negative 2. And we're going to lower the power by 1. And now at the end, we will rewrite this as 6 over x to the 4th. Notice we didn't rewrite it in the middle of the problem because we would have just had to bring it back to be a power. So as long as you're in the middle of a problem, you just like leave it as powers. So you can do power rule stuff, and then you rewrite it at the end. Okay, this one's cool, and this comes up on the AP exam somewhat often, where they're just like, hey, what if like y is equal to u times v, where these are functions. U and v are functions. Well, then how do you find the second derivative? Well, you start by finding the first derivative, and the derivative of these are multiplying, so we got to use the product rule. These are not constants. They said they're differentiable functions, not constants. Yikes. And so we are going to do the product rule. The derivative of the first, we just write it as u prime. The derivative of the first times the second left alone, plus we leave the first one alone, times the derivative of the second, which we write as v prime. That's the easiest way to write this, although there are other ways to write it as well. So that's the first derivative. Now the second derivative, we have a sum or difference, so we'll just do these each separately. We'll do this one first. This is a product, and so we'll do the derivative of the first. Well, what's the derivative of u prime? That's the second derivative of u. So the second derivative of the first one times this one left alone. So the derivative of the first one times the second one left alone, plus we're going to leave the first one alone times the derivative of the second. So I hope we can see that this is the product rule from this. Plus, now we're going to do the product rule on this one. So we've got the derivative of the first times the second one left alone. Plus, we're going to leave the first one alone times the derivative of the second one. And the derivative of v prime is v prime prime. This can be combined. This and this are not like terms. Here it's u prime prime. Here it's just u, so they're not the same. But these are the same. This is u prime prime v. I just left this one. This one doesn't combine anything, but these are the same. And so we have one of these plus one of these is 2 u prime v prime plus u v prime prime. And look up above. We had this product here, right? And so it's the second derivative of the first one. Well, the derivative of x is 1, and the derivative of 1 is 0, so that part goes away. Plus 2 times the derivative of the first one, which is just 1, times the derivative of the second, plus we leave the first one alone, times the second derivative of sine of x. The derivative of sine of x was cosine, and the derivative of cosine was negative sine, and that got us this. So this isn't like a super useful formula for our course, but it is something to know. And you could do actually a third derivative. And it actually, we talked briefly about Pascal's triangle earlier. It actually follows this pattern where if you have like 2 things multiplying and you do the third derivative, it'll come out to be like u prime prime v plus 3. It'll follow this pattern. 3 u prime prime v prime plus 3 u prime v prime prime plus, oh, did we do Pascal's triangle? Oh, guys, I said we had done Pascal's triangle, but that was in the part that was kind of like in that bonus video where we were coming up with the rules. But I think we actually skipped it this year, and you may not have seen that before. So I'm referring to things you haven't seen. I'm sorry about that. Okay. Let's talk briefly about what the second derivative means in terms of particle motion. So there is a component of the AP exam that is physics, that is like how do things move. And before we get into this, let's make sure we understand that if you have the position of something, so maybe it's the height of something or where it is, a lot of times they like to talk about like the position of a particle moving along the x-axis. And they'll just say like, hey, where is a particle at different times? So x of t is a position function that tells you where something is. So maybe like it'll be at 5 or something. So at different times, where is a function? Then the derivative, this is position. The derivative of x of t means how is the position changing at any time? So that's not about where you are. It's about like what direction you're going. Okay, and there's a word for this in physics, and it's called the velocity. The velocity means how is the position changing. It's a rate, so it'll be, so if this is like in meters, is like one way you might measure position, or feet. Then velocity is in feet per second or feet per minute. So something divided by time. So velocity is how many feet or meters or whatever you're moving by each time period. So how many feet per second are you moving by and in what direction? A negative velocity means you're moving to the left. A positive velocity means you're moving to the right. Just like a negative position would mean you're to the left of 0. And a positive position means you're to the right of 0. A negative velocity is about which direction you're going to. And lastly, and we write this as v of t. So the velocity is, I don't know why I put 2 equals here. The velocity is how are you moving? I hope you guys have all taken a physics course, or at least are taking one now maybe. I don't know. It's kind of important. But I actually need to do a poll of the class and see where we're at, because we might need to put in some extra particle motion stuff if we haven't. All right, but now we're talking about the second derivative. And the second derivative of the position means the derivative of the derivative. So the velocity is how is the position changing. The derivative of velocity means how is the velocity changing. So this is v prime of t. It's how is the velocity changing? So it's like, well, okay, it might be moving to the left, but is it moving to the left faster or slower? Is it moving to the right? Is it moving more and more? Is it moving to the right faster or slower? And this is called the acceleration. Those of you who drive, the accelerator is the thing you push to make the car go faster or slower. And as you're driving in a car, if you just like hold your foot constant on the gas pedal, your car is just going at constant speed. If you push it down harder, it makes your speed go up faster. Or if you let go of the accelerator, you'll still be going forward, but you'll just be going slower instead of faster. So you can change the speed your car is going, and that's called the acceleration, is when your speed changes. So the acceleration is the second derivative of position. It's how is the rate of change changing. So an acceleration is the second derivative. So we'll be talking about that a little bit. It's the rate of change. So the second derivative of the position of a particle in motion is the rate of change of the velocity. This is the acceleration. Find the acceleration of a particle at t equals 5 if the position function is given by x of t equals negative 3t squared plus 6t. So the acceleration will be the second derivative. And the first derivative we always call the velocity. We could put x prime of t here, but we don't need to. This is in terms of t's, and so the derivatives will also have t's in them, not x's. So what is the derivative of negative 3t squared? Well, this is the power rule. Negative 6, we lower the power by 1. What's the derivative of 6t? Well, that's just 6, because this is t to the 1 power, so we multiply by 1 and lower it. And it'll be t to the 0. So this is the velocity, but we want the acceleration, which is the second derivative. The derivative of negative 6t is negative 6. The derivative of 6 is 0 because this is a constant. And so we get a of t equals negative 6. It is asking for the acceleration of a particle at t equals 5. That is the acceleration when the time is 5. Well, this is a constant function. This says that the acceleration at any time is always negative 6. So the acceleration when the time is 5 is negative 6. So that's the answer, negative 6. This is asking for the acceleration function, a of t, if the velocity is given by v of t equals 6 sine of t minus 3t. So go ahead and try to find that. And hopefully you recognize we don't have to do the second derivative because this is already the first derivative. This is the speed, this is the velocity. And so the acceleration is just the derivative of the velocity. So the derivative of 6 sine of t is 6 cosine of t. The derivative of 3t is minus 3. And so this is the acceleration function. But because we were already given the velocity, this is like we already had the first derivative of the position, and now we're just doing the second derivative to get to acceleration. Again, this is stuff you should probably be familiar with a little bit from physics if you've taken a physics course, and I hope you have. I don't know. You'll have to let me know. At what time? And it's on the AP Calculus exam, so if you don't know it, we'll learn it, and we'll just spend some more time on it. You guys just need to tell me. At what time t, so we're looking for what time. We're going to be solving for t. At what time t will a particle with a position of 6t squared minus 24t have an acceleration of 0? Okay, well, here we have the position. And so how do we find the acceleration? That's the second derivative. Go ahead and find it. So first we'll find the velocity. That's the first derivative. This is where a particle is. This is how it's moving. And it's 12t minus 24. And the derivative of that, the acceleration, will be, so this is x prime of t. And this is the second derivative. The derivative of the derivative is 12, and the derivative of negative 24 is 0. So again, we get a of t equals 12. Now it's asking at what time will the particle have an acceleration of 0? Well, this function says the particle at any time has an acceleration of 12. And so we're looking for when does this equal 0? What time will make the particle have a position of acceleration of 12? And the answer is never. The acceleration is always 12, and it will never be 0. Okay, last one, and I want you guys to do this all on your own as much as you can. A particle is moving along the x-axis given by this. This is its position. So for instance, x of 3 means that when the time is 3, when like 3 seconds have passed by, the position of the particle will be 3 cubed is 8, 2 times 8 is 16, 3 squared is 9, 3 times 9 is 27, and so the position is negative 11. So this tells you that when the time equals 3, the particle will be right here. At t equals 3, the particle is at negative 11. That's what the position function is telling you. So what direction, and the direction is either going to be left or right, and it's going to be based on whether the velocity is negative or the velocity is positive. what direction is the particle moving when the time is 2? So the way a particle is moving is its velocity. Its direction is its velocity. And so we need to find the velocity. That's the derivative of position. It's how the particle is moving. So the velocity is 6t squared minus 6t, and we want to do it at t equals 2. So v of 2, that's when the time is 2. 2 squared is 4, so we get 6 times 4 is 24. 6 times 2 is 12. 12. So the velocity at time 2 is 12. What direction is the particle moving? Well, because this is a positive number, the particle is moving to the right. So we could write a sentence that says at t equals 2, the particle moves right because v of 2 equals 12, which is greater than 0. So it's a positive number. What is the acceleration of the particle at t equals 2? So we already found the velocity. That's the first derivative. This is x prime of t. The acceleration means how is the velocity changing? So the acceleration is the derivative of the velocity, which is 12t. I did the power rule. 12t minus 6 at t equals 2. So a of 2, the acceleration when the time is 2, is 24 minus 6, which is 18. When will the particle be at rest? So when will the particle be at rest? Resting means not moving. And so is this acceleration, velocity, or position? Well, the particle can be moving no matter where it is. Like even if it's at 0, the particle could be moving. It doesn't necessarily mean it's resting. Not moving is about velocity being 0. It means the direction the particle is going isn't left or right. And so to find this, we need to take the velocity, and we're not putting in 0 for t. It's finding where, at what t, so when will, we're looking for what time will the particle be at rest. So we found the velocity up above. Oh wait, that's the wrong problem. We found the velocity up above, and so we want, where is the velocity? Where is this equal to 0? So where is it equal to 0? This will be where the particle isn't moving. And this is a quadratic, so we factor 6t times t minus 1. 6t times t is 6t squared. 6t minus 1 is 6t. They had a common factor of 6t, so we factored it out. And so when is the particle not moving? Well, when t equals 0, because 6 times 0 is 0, or t equals 1. Both of those times, the velocity will be 0, and so the particle will not be moving. So when you put in t equals 0 or t equals 1, the velocity will be 0, and the particle will be at rest. Find the position of the particle when the acceleration is 0. So find the position. The position is x of t when, this is the time, when the acceleration is 0. So we have to first start by finding where the acceleration is 0. And we have our acceleration function up above. So we want a of t, which is 12t minus 6. When will this equal 0? Well, we can solve, move the 6 to the other side, and find that t must be 1/2. That's not the answer to our question. It said when the acceleration is 0, that's t equals 1/2. So when the time is 1/2, find the position. And so at the time of 1/2, the position we can find by plugging in here. This is 2 times 1/2 cubed minus 3 times 1/2 squared. 1/2 cubed is 1/8, so 2/8 minus 3/4. And 2/8 we can divide by 2 and divide by 2 and get 1/4 minus 3/4 is negative 2/4, which is negative 1/2. And that's it for the stuff we're learning for today. If we need to, we'll do some more particle motion stuff next class. One thing I want to show you, and this is something I've usually passed out at the beginning of the year, is, and you want to print this out if you have a printer and keep it with you. Usually I do it in different color paper, like usually I'll have it be a green sheet because it's worth pulling out pretty often, is what are the skills we need to know really, really well? And so one thing is we need to be able to write the equation given a point, x1, y1, and a slope, m. So how do you write the equation of a line given a point and a slope? This comes up a lot. This is from Algebra 1, and we know it's y equals m times x minus x1 plus y1. Write this down on this sheet. This is a reference sheet. It makes it really easy to just like have this one sheet that you refer to for like a lot of the stuff you're supposed to have memorized. Now we haven't done this yet. There was a lesson 1.1b that we skipped over because I was trying to make up for the 3 weeks that we lost. We'll come back to this later. So hold off on this stuff, using the tangent line to estimate and doing underestimates and overestimates. We'll come back to that later. The derivative rules. If we have h of x equals f of x plus or minus g of x, we want to say that we can always find the derivative by just doing them separately. So if you have two things adding or subtracting, we know that we can just add or subtract the derivatives and put them together separately. How about a constant multiplier rule? What if we have h of x equals c, which is a constant, times a function we know how to do the derivative of? Well, that derivative is, we leave the constant multiplier alone and do the derivative of the function we knew how to do the function of. How about the derivative of a constant? What if we have h of x is equal to some constant? What's the derivative? The derivative is 0. The product rule says if we have a product of two functions we know how to do the derivative of. Oops, g of x. How do we do that derivative? Well, the derivative is the derivative of the first times the second left alone, plus we leave the first alone times the derivative of the second. These should be memorized. The quotient rule is very similar. If we have two functions that are dividing, quotient rule is my least favorite, by the way. I always try to avoid doing it when I can. So sometimes you can avoid it, sometimes you can't. The derivative is, it's the derivative of the top one times the bottom left alone, minus instead of plus, leave the top one alone times the derivative of the bottom over the bottom squared. So the product rule and the quotient rule are fairly similar. We have not learned the chain rule yet. This will be in our next unit. It will not be on this test. Basic derivatives. What if you have the derivative of x to some power? Well, that's the power rule. N times x to the n minus 1. What about the derivative of sine of x? It's cosine of x. The derivative of cosine of x is negative sine of x. This is a new one from today. The derivative of tangent of x is secant squared of x. The derivative of natural log of x, we talked about this briefly. The derivative of natural log of x is 1 over x. The derivative of cosecant, hopefully we're starting to memorize these. The derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent. The derivative of cotangent is negative cosecant squared of x. And, oh, you guys couldn't see that? I hope you could see it. And lastly, the derivative of e to the x is e to the x. And that is all the ones we've learned so far. I would like to show you a nice trick that I think is worth memorizing. All the ones that have co in them, cosecant, cosine, cosecant, cotangent, those ones are all negative. Did you notice that they all have a negative? So the derivative of anything that starts with co will be a negative. And it's the exact same thing as the derivative of the one that isn't the co. So instead of cosine, the derivative of sine was cosine. So the derivative of cosine is going to be negative of the opposite sine cosine one of this. So negative sine of x. Check it out for tangent and cotangent. So tangent, the derivative of secant is secant squared. Cotangent, the derivative is going to be negative. And then instead of secant squared, we do the opposite one. So cosecant squared. Okay. The derivative of secant is secant of x, tangent of x. So the derivative of cosecant is negative, and we switch this, instead of secant, it's cosecant cotangent. Cosecant cotangent. So that will make it a lot easier to memorize, I think. Okay, so guys, memorize these. You're gonna make some flashcards, and every one of these things, this. Oh wait, they're also, man, I should have put on here. I forgot the back is gonna be. We also need the limit as x goes to c of f of x minus f of c over x minus c. This is the derivative at a point. This needs to be memorized. So the derivative at a point is this limit definition, and the derivative function is the limit. This is the one as h goes to 0 of f of x plus h minus f of x over h. And these, along with all of these, should be put onto flashcards and memorized. That's kind of your goal for tonight. So on the front, you should put something like the derivative of x to the n, or you could just put like f of x equals x to the n. And on the back, this is like front, back, put f prime of x equals n x to the n minus 1. And then you just flip them over, right? So like, let me show you what making this should look like. If you have index cards, that's great. But otherwise, you can just take a sheet of paper and like fold it into parts and make, oh man, it's gonna be so ugly. I'm not good at folding paper and cutting things. But you can fold it. I would do maybe 8 per paper. This feels like about the right size. So you can fold it the other way too, so it cuts easier. You can use scissors. You can also just like, you know, tear it if you fold it well enough. I should fold this one this way too. And cut it out. So make these cards something where you can practice memorizing some stuff. There's not a lot of memorizing in calculus, but hopefully yours are better than mine. But like on the front, put like f of x equals tangent of x. I guess I could just do this. And then on the back, the derivative. So the derivative is secant squared of x. And then test yourself. Okay, you can test it both ways. What thing has a derivative that's secant squared? Tangent. What thing has a derivative that's tangent? It's secant squared. And the ones you already know, don't spend a lot of time working on, but the ones you don't, you know, go ahead and make those. So you're making these with this, and I'll post which ones I want you to have on there. Okay? Hopefully you have a good day. If you haven't passed your mastery quiz yet, you can work on that. Have a good day, guys.